Hey everyone, and welcome to another episode of Coffee with Thorben. I hope you had a great week so far. Let me tell you, this week was crazy. Maybe you recognize on, I think it was Tuesday and Wednesday, I did a few changes on the site and added Cloudflare and a few fancy performance optimizations and stuff like that. And well, as it sometimes goes with performance optimizations, you sometimes break a few more things than you actually fix. But as far as I've seen in my tests and the traffic statistics and everything should be fine and fixed now. So please do me a favor. If you see any issues on the site, then please let me know and include a quick description on when and where all of that happened. But in general, if you go to torbenjanssen.com, then you should now recognize that the page is a little bit faster, a little bit more responsive than it was before. And I hope it stays like that. And yeah, that we don't find any additional issues that are added to the page. Yeah, besides that, I started working on the new Spring Data JPA course. I will officially announce it either in the second half of the next week or in the first half of the week after. It will be a course for everyone who's already familiar with the Hibernate and JPA basics, but who wants to use that with within the Spring stack and actually benefit from all these Spring features and usability improvements. But enough about that. Let's get into the first topic and talk about utility classes that you should know when working with Hibernate, because they make your life so much easier. As always, if you go to torbenjanssen.com/live, you will find a post for each and every live stream. Down here, all the older ones, and the one for today up here, with additional links to resources and all other things that I mentioned during the stream, or that I at least plan to mention during today's stream. Okay, so why did I pick today's topic? Well, mostly because I get a lot of questions about all these magic strings that you usually have in your code. You have a string that references an entity class by its entity name, or an entity attribute by its name, or a query hint that is a rather long string, quite often starting with javax.persistence. And then something. It's half of a sentence that's usually in that name. And all these strings are pretty uncomfortable to write, not that great to read, and let's be honest, pretty hard to remember. And there are better ways to do that. Luckily, the JPA specification provides us with a code generator that gives us the JPA Metamodel. That will be the first thing we will look at. And then there are a few classes provided by the Hibernate team that give us constants for query hints and other things we might want to set in our code. So let's get into the IDE and take a look at the JPA Metamodel first, and then add a few other utility classes. So what is the JPA Metamodel? You might have seen that in some tutorials online, maybe my videos or blog posts. There are classes that have an underscore at the end, and that might look a little strange in the beginning. So what is that? That is a class that was generated, and that is part of the JPA Metamodel. And as you can see here, it has a bunch of attributes: first name, last name, books, ID, version. Well, you might already guess it. These are entity attributes. Let's take a look at the author entity, which belongs to the same project. And there you can see that we have the attributes ID, version, first name, last name, date of birth, and books. And if we now go back to the author underscore class, then you can see here that we have similar attributes here. And where usually we have one attribute for each entity attribute in our Metamodel class. The Metamodel class itself is located in the same package as the entity. And then we have the same class name with an added underscore at the end. And then we have two blocks of attributes here. One with singular attribute, list attribute type attributes, and one with just strings. So the strings down here you can use to reference an attribute by its name. Just here with a way easier way than you would normally do. You have to type it. But the interesting parts are these up here, the singular attribute and the list attribute. Because let's go into a test case where we actually use it. Here I have the JPA Metamodel and the criteria API that works really well together with the JPA Metamodel. What do I do here? I create a criteria builder that is, well, a builder for the different parts of our queries. Then I create a tuple query and define my from clause starting on the book entity class. And well, that's pretty common stuff. And now we would usually select either various attributes from that entity or maybe create a where clause or something like that. And in all these cases, we need to reference specific entity attributes. But instead of strings, we now have here these references with book underscore dot title, book underscore dot publishing date. And if we take a look at the book underscore class here, then you see that this is basically the same as I showed you before with the author and author underscore class. So again, it's a Metamodel class with an added underscore at the end. And without that, it would be the same name as the entity class, an attribute for each entity attribute, and then a list of strings down here. Yeah, and these provide a pretty simple way to reference the attributes. We can use the same down here in a where clause where we have author underscore first name in our where clause. And instead of using strings, we now get, we can now use these constants. And if we take a look at the SQL statements, then you can see here that, let me scroll that like this. So here we had the author underscore dot first name, which we got from our root interface, which is the author entity, and that resides in this part here in the SQL statement. So Hibernate treated it in the same way as a string with the content first name. The benefit here is that these Metamodel classes, first of all, are way easier to use. Instead of remembering which attribute names there are, I can just use code completion in my IDE, and I get suggestions for all the attributes that are there. And I don't need to remember what that one called, first or first name or F name or whatever. There's just a code completion for that. Then we have additional type information that, depending on the API you are working with, can be really beneficial. For example, here in a criteria query, you could benefit from the information that this is a singular attribute or a list attribute, and the criteria API can then use the typical Java language features to just cater certain methods to all kinds of list attributes, for example, or to limit them to singular attributes or similar things. Then the question is, how do we get these classes? I already mentioned it, they are generated. But how do you do that? Well, it's pretty simple. You just add the Hibernate JPA ModelGen dependency to your project. That one hooks into your build process and then generates these classes at build time, which is great because if you now decide to change the entity here in some way, change first name to F name, for example, or change the data type of an attribute, then during the next build, the Hibernate JPA ModelGen component would just take the entity class, regenerate the Metamodel class, so regenerate this class, update all the names here, and all the places in which you used the old first name attribute, which now should be called fname, will throw a compiler error because the attribute first name no longer exists. It's now called fname. And you can easily go through your code, fix all these references, and after that, you can be absolutely sure that your application works again as it did before, which is, yeah, not the best tooling that we could hope of, but it's by far better than using the search and replace feature of the IDE and just hope that you find all the first name attributes that actually are used by this author entity and not by some other entity that has the same attribute by accident. Okay, so that would be the JPA meta model. Yeah, do you guys use the JPA meta model in your projects, or is that something that's new? Would love to get your feedback on that. So the next thing I want to show is, so we have a short delay here between me streaming this and until that's live on all these social media platforms. So feel free to post in the chat, and I will get back to your answers in a second. And if you have any questions about the JPA meta model, please post them now, then I will do my best to answer that questions immediately. Okay. So the next thing where we have annoying strings in our application is when we are working with query hints, for example. So here I want to set the timeout for a database query. Right? With standard JPA features, I would need to set the string javax.persistence.query.timeout. Well, the chance that you mistype something here is pretty high, and let's be honest, I have a hard time remembering all these strings. I mean, there are a bunch of query hints. On the post for today's stream, you can find a link to an article where I describe I think it's the 11 most important ones. So yeah, there are a bunch of them. And who wants to remember all of them? I don't. And so there's an easier way than writing them as a plain string. And that is using Hibernate's query hints class. And that one is great. It was added in, I think it was Hibernate 5.2. So rather recently, Hibernate 5.2 or 5.3, where we got the query hints class. And as you can see, here are a bunch of public static finite strings that provide constant values for all kinds of things you might want to set. And you always need to be a little bit careful. There are two query hints classes, and better always check both of them. So there is one called query hints in the package org Hibernate JPA, and there's one in the org Hibernate annotations package. And in the one in the annotations package, you can see the actual string values. So cache region would be org Hibernate cache region. And then we have here the persistence query timeout that I just used. Can set log modes, fetch graphs, all these kinds of things. So yeah, whenever you want to set a query hint, check these two classes for constant string. The one in the annotations package is the more complete one. But yeah, if you need to implement a portable application, I would always check the org Hibernate JPA query hint section first. Okay, let me quickly take a look at the chat. So there are quite a few who said it's a new feature to them, and yeah, so my recommendation there is give it a try. Go to your POM XML or your Gradle build, In the Hibernate documentation, you can find a simple explanation on how to integrate the ModelGen component into your Gradle build. And then, yeah, you get these classes. And one thing I didn't mention, and that is the location where they're added. And if you're using Eclipse, for example, you need to make sure to include that folder as a source folder. So in a typical Maven build, you have your Metamodel classes at source main, and then Java, and then the package, right? In this case, it's org thoughts on Java model. And the Metamodel classes get generated to target generated sources annotations, and then the full package name as in the Java source folder. So make sure if you're using Eclipse that you add this annotations folder as a source folder so that Eclipse finds these underscore classes. And yeah, Kirikou wrote that he or she is already using it and trying to get the rest of the team to adopt it. Yeah, that's highly recommended. And I would say if you write a few lines, or maybe you should find a link about the JPA Metamodel, an article about the JPA Metamodel on my blog, maybe send them a link to it and quickly explain what you can do with it and what you need to do to keep it updated, which is basically nothing. Then it should be an easy thing to convince them to use it. And Tiago wrote that he's using the JPA Metamodel, although he's considering Criteria API too much verbose. Yeah, I agree. The Criteria API isn't the nicest or most easy to use API, but on the other hand, after you wrote a few queries, you quickly recognize that there's a very small set of concepts and API patterns that you can use to build that query. And while yeah, it's pretty verbose and it might be a little hard to read in the beginning, technically it's a good API that is well designed and that gets easy to use after a short period of time. The only thing that I don't like too much about it is that there's a pretty high distance to the actual SQL statement that you're creating. So if you have the SQL statement you want to write in mind and then start writing the criteria query, there's quite some work you need to do. So Saga asked, do you know if it's possible to set log timeout for Postgre database using query hints? I think PostgreSQL only supports no wait. Well, all these query hints are just hints. I mean, these are just things that you want to tell your persistence provider to maybe apply to the query. And some of these hints are well supported by the persistence provider, but the actual feature happens on the database side. And there you always need to check what's supported by your JDBC driver and what's supported by your database. I'm not 100% sure about the support of that hint in Postgres. No wait definitely works. A query timeout in milliseconds, I think isn't supported, but that is something that, as I said, is database specific and that you would need to double check there. It's nothing that Hibernate can do about it. Okay, so we had our query hints here, and we had a look at the 2 query hints classes provided by Hibernate. There's another thing that I want to show you, and that is the graph semantic class, which is pretty similar to the query hint class, but which basically keeps the query hints that you need for entity graphs. So I explained that in great detail in the past. The entity graph is a JPA feature introduced in JPA 2.1 that enables you to define which entity objects shall be fetched together with the query. And the definition of that graph is independent. You can define it via the Entity Graph API, as I do up here, where you can use the JPA Metamodel as well. Or you can define that using a named entity graph annotation. Totally independent of how you define the graph, at some point you need to connect the graph with the query. And you do that by setting a query hint. And there you again have to provide a string like this JavaX persistent fetch graph, and then there's also JavaX persistent load graph. And where you can set it as a string, or you take the graph semantic class, and then you can see that you have a graph, a fetch graph or a load graph. And then you can get the JPA hint name from it and set the graph there. No magic strings, nothing there that you need to remember from a syntactical point of view. You just can focus on the actual feature that you want to use, which is how it should be, right? So let's focus on the stuff that's really relevant and not some magic strings. And that's why I always recommend to use graph semantic class or the query hints class or the JPA meta model that we saw here. That gives us an easy way to reference entity attributes in your code. Okay, let's take another look at the chat before we go to the weekly recap. Hi, Neo Revolutions, great to have you. Yeah, Saga, was my pleasure. I'm sorry that I can't be more precise about the PostgreSQL support there. As I said, it's database dependent and it might even switch between database versions. And C. Nicola wrote, love your course, thank you. Yeah, thank you. Thank you very much for being one of my course students and yeah, for talking positively about it. May I ask which course you're currently taking? Okay. And George asked about a video about tagging in Spring. I will think about that. Let's see. Right now, well, I've planned the content for March, so all the blog posts and videos for March are already planned, and a few are already in preparation. But yeah, after that, I will think about it. I put that on a list for blog topics, and then we see if I will be able time-wise and from the overall scope of the topic to do an article about that. So yeah, if you enjoyed this teaching section here, and if you like the other videos that you can find on my YouTube channel and everything, then you can of course take a look at my online courses. But one thing I want to especially point out is that I'm doing live online workshops this year. One workshop every quarter. We start with one about Hibernate performance tuning. So there we take a look at mapping pitfalls, at optimizing read operations, caching, how to optimize write operations, all these good things. So that is a 3-day live online workshop. Takes place from the 20th to the 22nd of April. Then we will have, of course, a live workshop about Spring Data JPA in June. Talk about data and communication patterns from microservices. So how do you exchange data reliably between two services without introducing strong dependencies or anything. So that will be topic of that workshop in September. And then we have at the end of November, beginning of December, a workshop about advanced Hibernate features. So things like supporting custom data types, building multi-tenant applications, mapping lifecycle structures, reacting to lifecycle state changes and stuff like that. Okay, so Saga just confirmed that PostgreSQL driver unfortunately doesn't support the log timeout, the query log timeout hint if it's not a no wait. Yeah, exactly. You can quite often set something as an option string in your JDBC connection URL, but then that again is something database specific where you need to see what's supported there. So that's always the case with Hibernate and with any other Java framework that interacts with the database. At some point, they need to call the JDBC driver that connects to the database. Well, and they can support more than the JDBC driver does. Query timeouts, transaction timeouts, all these things need to be handled on the database. And well, either the database supports these things or it doesn't. And if it doesn't, then there isn't anything Hibernate can do about it, unfortunately. Okay, let's get into the weekly recap. So what did we do this week? So this week, I published an article about Hibernate performance tuning and how to do it right. That was a topic that I wanted to write about for a while now, because I, in general, see two things there. Either people follow some guidance from static code analysis or from best practices articles and everything, and just blindly follow that and then say, well, now I did everything and the performance should be fast or should be great. Unfortunately, if you do it like that, then you spend a lot of effort on performance optimizations that are not relevant for your application, because they might be right and might avoid performance issues if you work on huge data sets, but well, if your query only returns 5 records and or if an association never has more than 3 records based on your domain model, then you don't need to spend any effort on a performance optimization that makes sure that associations with 500 records don't slow down your application and stuff like that. So you put a lot of effort into things that will not change the user acceptance of your use case just because you are saving a millisecond or 2. At the same time, you're missing all the things that are use case or application specific that don't follow a general best practice. Because your application is special, your domain model is special. So you're missing all of that. And while you put a lot of effort into optimizing the stuff that's not relevant for your application, you miss the ones that increase the execution time of a backend call from, I don't know, 10 milliseconds to 5 seconds, and the user start complaining. So it's important that you take the right mindset when working on performance, and that is only focus on the stuff that's a performance issue and only start working on it when you're sure that it will be an issue soon. Doesn't make any sense to now fix a performance issue that might become relevant in 2 years. Until then, you probably changed that use case 2 or 3 times, and the question is if you will ever reach that point of in regards to the amount of data and the load that you get for which you estimated that performance tuning problem. And well, if you do that, then the question is, how do you actually find the things that you need to optimize? And there are 2 ways you can find them. One is activate Hibernate statistics. Then you get something like this here, the second box, where Hibernate tells you, okay, that many JDBC statements were executed, it took that long, we had these cache interactions and so on. And you can then analyze all of that information and identify the performance issue and fix it. The second option is you take a look at my perf tester tool, which hooks into Hibernate, collects the same statistics and a little bit more than you see with Hibernate statistics component up here, automatically analyzes it, and then tells you, okay, in that specific class, you fetch, and line of code, you fetch this association that many times, and that causes a performance issue. You should better adjust the query here that loaded that entity and make sure that you don't run into that performance issue. And similar things. So there are a bunch of performance tuning recommendations and analysis that are automatically run on the code base there with PerfTester. And as I said, if you don't want to get PerfTester, just activate Hibernate statistics. Take this block. Here are a few more links in the text that show you how to analyze and fix these different issues, and you'll find more resources about that on my blog and on the YouTube channel. And then I published another video on Thursday. So every Tuesday there's a new article on the blog. Every Thursday there's a new video on the YouTube channel, and Fridays we do the live chat here. So yesterday we published the video that you can see here about initializing entity associations with Spring Data JPA. Because Spring Data JPA is based on JPA, you can of course use all the features that you know from JPA. But with Spring Data JPA, a few things get a little easier. And I explain all of that in that video. And as always, you can find a link to the corresponding article here in the video description. And again, if you want to find links to all of these things that I just mentioned, go to torbenjansen.com/live. You can see the link down at the bottom of this video. Okay, enough talking about content of this week. Let's get to the question of the week. I answered that a few hours ago here on Stack Overflow, and there was someone who wanted to get an instance of a mapped superclass with the entity manager, and well, there might be a few issues hidden in that mapping. That's something that we are still discussing. But there was one general misunderstanding that I see quite often. So that person wanted to have an abstract superclass annotated with mapped superclass, and then have subclasses in different modules, which are then entities and which then can be loaded from the database. The issue with that is that the mapped superclass annotation tells your persistence provider to share the mapping information from that superclass with all subclasses. Oh, sorry. Here you can see now you can see the question on Stack Overflow. So the issue with mapped superclass is that you don't make your superclass an entity. That superclass stays just a normal Java class. And due to that, you can't use it in association mappings, you can't query it from the database. It's just a Java class that shares the mapping information with all its subclasses. That can be totally fine, especially if the subclasses are totally independent of each other. But in general, the table per class strategy is the better way to map such an inheritance hierarchy, because then you can use the superclass in association mappings. You can query the superclass, and that works way better than with the mapped superclass in the long run, in my experience. So I always recommend, if you just want to map each subclass of an inheritance hierarchy or each concrete class of an inheritance hierarchy to its own database table, make sure to use table per class and not mapped superclass. I explained that in great detail in the article that I've linked here at the end of that post. So the short summary is, if you annotate the superclass with inheritance and set the hierarchy, the strategy to table per class, then each concrete class will get mapped to its own database table. And you can then use, in this case, the manufacturer to model an association, or in your query, and Hibernate will then select all the, create a query that selects over all the tables that are mapped by one of the classes in that inheritance hierarchy, joins all of that into a result set, returns that, and then maps each record in there to the specific subclass. So if you have a product here, then Hibernate would get it from the database and read and return a product entity and not a manufacturer entity. Yeah, that's the question of the week. If you have any questions about that, or if you want to dive into any parts of the inheritance mapping a little bit deeper, then please feel free to post that in the chat. And I'm happy to answer that as well. But for now, let's take a look at the chat and get to the Q&A part of today's stream. So Saga wrote, first of all, you're not asking too many questions, Saga. Ask as many questions as you want. So just go ahead with your questions. So he wrote, when I use delete all by foreign key ID, UUID foreign key, deletes one by one and clears first level cache. And then we have a modifying query, delete from student where, deletes all records in one go, but does not clear first level cache immediately. Now my question is it possible to clear cache without with second query? No, what you can do is you can do a flush and clear on the cache. So let's take a look at an example. I'm sure I have some where the JPQL update example runs into the same situation. So let's take that one, JPQL or JPQL delete, same. So what Saga described in the chat seems to be Spring Data JPA based, most likely, where you just annotate your repository method with a modifying query annotation and then delete the then provide the statement that deletes the records in contrast to a provided method that deletes all records programmatically. So what we usually have is when we execute a query and fetch all entities from the database and then call the remove method on the entity manager for each of them, then each of these objects gets fetched from the database, transformed into an entity, and then it goes through the typical lifecycle state transitions. So from managed to removed. And during the next flush, Hibernate generates an SQL delete statement and sends that to the database. The issue with that is that it creates a specific SQL delete statement for each and every entity, and that gets rather slow if you need to delete a lot of records. But each of these entity objects goes through the expected lifecycle state transitions, which ensures that all the caches are in sync, which ensures that all lifecycle listeners are triggered, and so on. If you can avoid that, so if you don't have any lifecycle listeners, for example, and if you can make sure that you invalidate the corresponding records in the chat or objects in the caches yourself, you don't need to take this approach. Then you can use a modifying query and do something like this, where I here just delete all the books in the table, and by creating a JPQL query and then calling execute update. That is what Saga's modifying query example does. So if I take this approach, then as I said, we don't have any updates on the cache. And what you should do before you execute that query, and I mean directly before you do that, is to call the flush method on the entity manager and the clear method. Calling both of them is important. So clear removes all objects from the first level cache. The problem with that is it removes all objects without doing any checks. So if there are any dirty objects in your first level cache, they are gone afterwards. So you're losing the update or remove operation that you already performed in your business code, but that wasn't sent to the database. That's why we need to do a flush first. That flushes all changes to the database, then the database is up to date, and we have no dirty changes in our persistence context or first level cache, and then we can call it the clear. And after that, delete all the records from the database. Yeah, I prefer doing that immediately before the JPQ statement. You could theoretically also do it immediately afterwards. My idea why I want to do it first is I always want to make sure that the database has all the information that it might need. And then when we are doing this, we are always doing two flushes on or potentially doing two flushes on the persistence context. One here and one there. And this one here clears the persistence context. As a result, this flush here is performed on 0 entities. And that could be a little bit faster. Is that relevant for most applications? Probably not. On the other hand, using this approach, it doesn't require more work than doing the flush and clear after the query. So why not get a minimal performance benefit out of it? It doesn't cost anything. And I can be absolutely sure that the database has all information before my statement gets executed, which is also a good thing. Yeah, Saga, I hope that answered your questions. The thing you need to do is you need to flush and clear your persistence context. There's no other way to get to remove the records from the first level cache. Otherwise, they stay there until the end of your current session, which usually is until the end of your transaction. The same is true for all update statements. There you would keep the outdated old version of that entity if you also updated it using a JPQA statement. So yeah, whenever you do a modifying query, first do flush and clear. Okay. Tomato wrote, is there any way to know what called a function without having to throw an exception and pass the stack trace? Exceptions are expensive in JVM time. Could do tracing or log each function call from the level below, but was wondering if there are any cool tricks. Sorry if out of topic. What could you do there? No, using either throwing an exception and then checking the stack trace, which obviously is only an option for development time, or using a profiler. No, I have no other idea. So the least invasive approach would be to use a profiler and just see how often that method is called and what's the path through your application to that thread took to get there. Yeah, but the simplest one is probably to just throw an exception and take a look at the log file. Even though that's not the nicest or cleanest approach. Okay, I think I caught up with all the questions in the chat. Are there any other questions? Let's see, I will double check if there's any question that I missed. So there was someone in the beginning there, Muni Gadapa, with connection issues to an Oracle database. Yeah, please provide a few more information about what you're doing right now and what kind of error you get. Then maybe we find a solution for that, if you're still there. And Amrita wrote things to be considered when there are multiple databases connected to your Spring Boot application. Excuse me. There are a few things you should consider. The first thing is, so I expect you're using all of them in the same transaction, right? So you would probably have, well, if that are totally independent databases, you would probably have a persistence unit, which means a set of entities and a configuration for each of these databases. So the things you need to keep in mind is you can't easily define a query that involves entities from both persistence units, which means tables from both databases. But you're probably already aware of that. The next thing you then need to make sure is that you handle your transactions in the right way. You're now creating a transaction that involves multiple systems. So more than the two that you usually have, which is your application and your database. You now have your application and 1, 2, 3, or how many ever databases. That then requires a distributed transaction or an XA transaction. That requires a little bit of extra configuration. That's not a big deal. That can be easily solved. The main issue there is that XA transactions are rather complex and slow, and that's why they are usually not used with a highly scalable microservice environment. You use them a lot in monolithic applications. So how does a distributed transaction work? Let me quickly see. I wrote an article about that. And I think there is an image in that article that I would like to use to explain how the distributed transaction works. Let's see. There it is. So let's go this and try to zoom in a little bit. Okay, so here you can see the simplified flow of a distributed transaction. So with a simple transaction, we have our application and the other database. And our transaction sends a start transaction and a commit, and that's it. Pretty simple flow. With a distributed transaction, that doesn't work because after you send a commit to a system, your changes are permanently persisted. There is no way to roll back a committed transaction. That thing is over. So if you can't take back what you committed before, then you need to make sure that when you commit your transaction and multiple systems are involved, that all systems will be able to commit the transaction. Makes sense, right? So what you do then with an XA transaction, which is then called a two-phase commit, and that is you introduce a transaction coordinator, which usually is provided either by your Spring Stack or by your Jakarta EE application server. So, and then you tell your coordinator to commit the transaction. And that coordinator knows which systems were involved in that transaction. So the coordinator then sends a prepare to each and every system and waits for the response. What the database then does is it gets the prepare command, and then it checks if it could theoretically commit the transaction. And if that's the case, then it responds with prepared. If all systems involved in that transaction send back a prepared confirmation, the coordinator goes ahead and commits the transaction on all of these systems. So you already see it's a little bit more complex than it was before, but it gets even worse. And the problem is the time between the prepared response and the commit command. Because during that time, the system needs to ensure that it will still be able to commit the transaction when it gets the commit command. And the only way to do that is to lock everything. So to basically make sure that no changes are applied to the records that were part of the transaction, or that could change the result of the transaction in any way. So that means with an XA transaction, you introduce logs to your system. And as soon as one of the involved systems fails, the whole transaction fails. So it's way more likely that something will fail. And you add a lot of technical complexity to your system that negatively affects the performance. Which, on the other hand, we accepted when we build huge monolithic applications, and we handled a lot of load with that. So you can handle a lot of load with that. What you can't do is, or where it gets difficult is, if you want to build a huge web scale application like Twitter, Facebook, Netflix, stuff like that. The typical smaller business applications that serve several hundred users at the same time, these kind of applications probably work totally fine with the XA transaction at the two-phase commit. Yeah, and besides that, there's not much you need to keep in mind. With XA transactions, the handling of multiple databases within the same transaction works totally fine. So what you do there is you configure your XA transactions in your environment. You make sure that you have database connections to each database system configured. There's one persistence unit for each database system that contains a set of entities, and then you can work with them. Okay. I hope that answers your question, Amrita. Lasse wrote, Oracle have a data type, XML type. How to map this with JPA? By using a custom type. Let's see, I will post a link to the chat. It is custom data type. So that data type shows you what to do for a PostgreSQL specific JSON-B type. But that's basically the same as an Oracle specific XML data type. So you implement a custom user type, and then you're good to go. So here where is my user type? There, you implement Hibernate's user type interface, set the two types, the one on the database side and the one in your Java code. And then you implement niceSafe get and niceSafe set methods to get the value from the database and to set it on insert and update statements. And then there are a few additional methods you need to implement. But I explained that here in the article that I just posted into the chat. Okay, what else do we have? Petia wrote, if I want to specialize in Hibernate like you, what are the other things I should learn besides Java, JPA, and Hibernate? SQL and relational table models. That are the basics, and then you can take it from there. But JPA and Hibernate always generate SQL statements, so you need to be able to understand and read and write these statements yourself. You will need to write a lot of native queries in more complex scenarios, so you should have a solid understanding of SQL. And then, well, you're working on a relational table model in a relational database. You need to be familiar with that stuff as well. And then you have the foundation that you need. In the next step, you then need to work on lots of projects and analyze them for performance issues and try different ways to solve that. I mean, that's the main benefit that you get from specializing in this. The tool set that you need and the features that Hibernate and JPA provide to analyze and fix performance issues is relatively limited. I mean, yeah, there are a bunch of them, but it's not that there are thousands of them. The tricky thing is to quickly figure out which approach do you need to use in this specific situation, and why are the other performance tuning features that might look like they are doing the same not a good fit for this specific use case. And that's where I bring my experience into my consulting projects, by being able to immediately identify, okay, this is a typical case where that specific feature helps. So that would be my suggestion for you, Pitya. Learn about SQL and relational table models, and then just work on projects. Saga wrote, with multiple instances, Spring Boot applications, and having database migration tools like Liquibase, because both instances have Liquibase, and sometimes it creates problems. To solve that, we moved Liquibase migration out from service and doing separately before deployment, but sometimes migration passes and deployment fails. Now system is unstable. Do you know how can we handle it less error-prone manner? Yeah, there are. Well, there are different approaches to that. Quite a few teams handle that in their deployment scenario. They just start up one new service that performs the database migration, and after that one started up successfully, they start up the rest of them. And then you can look into the tooling of your application stack. Usually they provide something there as well. But I have had pretty good results with handling that in the deployment and not in the application itself. So what you usually have there anyways is you have the old application still running, and then you start up new instances of the new version of the application. So what you do there is you split your available VMs or servers into two groups, one with the old instances, one with the new ones. And then you just start up one new instance. And as soon as that is running fine, you start shutting down instances on the old group and starting up instances in the new group until the old group is empty and the entire load is handled by the new group. That usually takes a little bit of time depending on your client interactions, because then you might want to make sure that a session that was started is still running on the old instances and doesn't switch to the new ones and stuff like that. But that then again is something that's deployment specific. That's not really related to the database. Emil asks, hi, why lazily fetched entities are type of entity proxy instead of entity? All lazily fetched to one associations are type of a generated proxy if you don't use bytecode enhancement. And that's because Hibernate otherwise can't handle the lazy loading feature. So if we have a publisher who published a book, then we have a many-to-one association on the book. So on the book entity, we have an attribute of type publisher. And that type publisher is our specific entity class. So Hibernate doesn't have any interface or something that it could implement to provide the lazy loading functionality. So there are two ways. Hibernate can either change the code of the getter method, that's what's done by bytecode enhancement at build time, or Hibernate can dynamically at runtime generate a subclass of our publisher and add the lazy loading functionality into that subclass. So there the subclass basically checks or keeps track if that object was fetched from the database, and if not, then it triggers an SQL statement as soon as you access a non-primary key attribute. Lucas wrote, do you have any recommendations of using migration libraries, for example, Flyware in clustered environments? Yeah, what I basically said earlier to Sagar, make sure that you handle the, make sure that you avoid running multiple updates in parallel, either by using additional tooling on your application side or in the deployment. That would be my general recommendation there. Amrita wrote, in microservice application, this might be a huge game changer. I definitely will check out your article. Amrita, we spoke about the transaction thing, right? Yeah, we did. So yeah, in a microservice environment, we try to avoid distributed transactions. They're the general idea, and that is one of the main topics of my whole data and communication patterns course is that one service has one database and that it only accesses its own database and that it uses a local transaction with that one, but no distributed transactions. And then there are different mechanisms that you can use to asynchronously replicate data or to make synchronous service calls as reliable as possible, even though I always recommend to avoid them and use asynchronous data replications, for example. And then we also talk about different patterns that you can combine to implement reliable asynchronous write operations that ensure data consistency over multiple services. That's a rather complex topic. That's usually the topic where people start thinking about creating their microservices a little bit bigger, making them a little bit less micro, to avoid building too complex systems there. But yeah, there are different approaches to that. So let me quickly post the link to the distributed transactions in distributed transactions. Post the link in the chat, and yeah, from there you will find more links and information on my blog about that, including the dual write issue, which occurs if you write to multiple databases without using a distributed transaction, which replaces the performance issue with a data consistency problem, which you should better not do. And yeah, if you want to dive deeper into that, I recommend also taking a look at my data and communication patterns course. Yeah, Tomato, thanks for joining in on the discussion. And I agree, yeah, with the issue that Saga described earlier. That sounds more like a release problem and not a software problem, but that's something that we would need to analyze in detail in that specific situation. So final question from Tomato before the end this week's stream. And he asked, my current application uses EHCache for layer 2 in Hibernate. I see it's possible to programmatically use EHCache separately for other purposes. Do you have any recommendations for distributed caching? Well, distributed caching is always a specific topic that depends a little bit on, no, that depends a lot on the cache implementation you're actually using. So my recommendation there is make sure that you have a very solid network configuration and a very reliable network. I ran into lots of issues especially at on-premise installations, where it was said that the network is absolutely perfect and reliable, and we were losing stuff left and right, and it was horrible. So that happens every now and then make sure to study the documentation about replications and and invalidation strategies used by your cache configuration, and then put that whole thing under load and see that it really behaves in the way that you expect. If you're using one of the popular cache implementations like EHCache, like Infinispan or Hazelcast, and there are a few more, then all of that are problems that are already solved. You just need to make sure that you apply that solution in the right way to your application, and the only thing that helps there is to study the documentation and to run extensive tests. But don't get scared by any of what I said here. It's not as bad or difficult as it sounds. All these standard scenarios are, as I said, already solved, relatively easy to set up, but it's a complex topic, so calculate a day or two to get familiar with that thing. And then, yeah, Amrita mentioned Redis in chat. I haven't used Redis myself, but I know that it's a very popular thing, and that a lot of projects are using it quite successful. So I would expect that you shouldn't run into any issues there. Yeah, Tomato, you're welcome. Good luck with your research. It's an interesting topic. I think it's a lot of fun to learn and read about that. And yeah, if you have any questions that are persistence related to that, feel free to join on one of the next live streams, and maybe I can help out with that. But there need to emphasize I'm focusing on Hibernate and JPA, right? Not on Redis or any other specific cache implementation. But well, if you have any questions there, feel free to ask, and we see if I either can answer them myself, or if maybe someone in the chat has an idea there. So let me quickly check what's planned for next Friday. So next Friday, 3 p.m., same time as this week. I will be back with another Coffee with Thorben live stream. And the plan for next week will be natural versus surrogate keys, and the different ways to map that. So how can you map a natural ID with a primary key? How can you map surrogate or technical keys? And which approach should you use? And why are so many projects relying on surrogate keys, even though there are natural keys that would be actually totally fine? Yeah, so we will do a comparison there. If you have any questions about primary keys, bring them to next week's stream. And until then, I wish you a great weekend, an interesting week. Lots of fun at work and not too much overtime. And yeah, thanks for joining. Stay healthy and see you next week. Bye.